Hello class, today we are doing lesson 12.1 line plots. So here we are on page 863. Students in Mr. Cotter's class were asked how many after-school activities they have. Their responses are shown in the table. So we're going to make tallies. Tallies look like this, where we make simple lines, and for the number 5, we cross it like that. So first, 0, and I'm going to do this in an easy, nice way. Got a 0, cross that off. Got a 2, cross it off. Got a 1, cross it off. Got a 3, cross it off. Got a 1, cross it off. Got a 1, cross it off. Got a 3, cross it off. Got a 4, cross it off. Got a 2, cross it off. Got a 1, cross it off. Got a 0, cross it off. Got a 1, cross it off. See, I did the 5. Got a 2, cross it off. Got a 3, cross it off. Got a 2, cross it off, and got another 1. Excellent. So that's the answers that we've got in our tally so far. So this is a great way that we can identify it. Now, turn the table so that the numbers of activities is along the bottom of the number line. So essentially, if we did this, we would be turning our table, just, take it and kind of turn it, like turn it like that way so that it's up and down. And we see here that's because there's 2. So for number 1, we had 6. 1, 2, 3, 4, 5, 6. For 2, we had 4. 2, 3, 4. For 3, we had 3. And for 4, we had 1. Now, that's a line plot. It's called a line plot because, as we can see, this is a line. That's it. So, one way to give a picture of data is to make a line plot. A line plot is a visual display of distribution of data values, where each data value is shown as a dot or other mark. It's usually an X, but it could be a dot, it could be a star, it could be a heart. Just like I said, it's kind of like a variable above the number line. A line plot is also known as a dot plot because they are dots. We typically call them line plots. I want you to copy this down into your math notebook, please. So excellent. They're called line plots or dot plots because it is a line or it can have dots. So let's look at this problem right here. Jasmine asked her class how many pets they had. The results are shown in the table. Make a line plot of the data, then describe it. So this has already done it for us. They counted all of these, which I'm glad because I don't really feel like counting them. But let's identify. We have 4 zeros. Let's check. We have 1, 2, 3, 4. Excellent. So as we see here, we got 4 zeros. Let's check our number ones. We have 1, 2, 3, 4, 5, 6. Is that how much we have? Yes, that is. So that's how I like to check it. I like to kind of go in order. For 2s, we are supposed to have 1, 2, 3, 4, 5, 6, 7, 8. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. Yes, we do. For 3s, we're supposed to have 4. 1, 2, 3, 4. Excellent, we do. And then lastly, for 4, we're supposed to have 2. 1, 2. Excellent. So we see that. And then it says, describe the data. If we added them all together, what it is 24 students responded to the question. No one has more than 4 pets, and 4 students have no pets. The response given most is 2 pets. So as we see this, 2 would be our mode. If we were doing our median again, we would have to count all of these. So by doing the median, you think, oh, our median's going to be 2 as well. But we have to cross off biggest, smallest, biggest, smallest, biggest, smallest, biggest. I'm going to do it with dots instead because it's kind of making my life a little bit harder. So, biggest, smallest, 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 biggest, smallest. And even though we could keep canceling biggest, smallest, we know that it's in 2. So yes, our median happens to be 2. And then if we did our mean, once again, we would have to add up all of these numbers. So this is 0. This one we get here is 6. This one we get here is 2, 4, 6, 8, 10, 12, 14, 16. So we get 16 here. We get 3, 6, 9, 12. So we have 12. And then we have 8. So if we have that, what it would be here is we're trying to find the mean of the total number of pets, not the mean of how many pets there, how many people's pets there are, anything like that. But we find this. We would add them all together and divide by how many there were. There are 24 responses. So if we added all of these together, we would have 0 plus 6 plus 16 plus 12 plus 8 is 42. We divide it by 24. We get people have an average of 1 75/100th pets. Now, mind you can't have 75/100th of a pet, but that's what the average is. So let's look at this one. Javier asked the members of his 4-H club how many projects they were taking. The results are shown in the table. Make a line plot of the data. So then describe the data in the graph. So once again, I'm going to do it the way I like. Let's do zeros. There's a 0. That's it. Let's do number 1 now. We got 1, 2, 3. So 1, 2, 3. Let's do number 2 now. We got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Let's do number 3 now. 1, 2, 3. So we got 1, 2, 3. Then we're going to do number 4. So we got 1, 2, 1, 2. And then lastly, we have number 5, 5, 1. There we go. Describe the data in the graph. What we can see here is that is our mode. It's the most common. And what we see here is that there was a total of 15 people who replied. Nobody had more than 5 projects, and 1 person had 0 projects. On average, people had 2 projects. Again, if we wanted to find what the average actual number was, we would add all of those together. You can describe the set of data using a measure of center as well, just like we showed. So here, we were trying to find the median and mode of the set. So if we have all of this, there are 16 hat prices in dollars represented in the line plot. The median is between the 8th and 9th piece of data. We found that simply because we did our boop, boop cancels. So if I did my boop, boop cancels, boop, 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 and there I'm left with those 2, which is between 8 and 9. So I find out that it is 8 and 5/10. The 2 middle numbers shown on the line plot, however, are 40 and 45. So if I was trying to find that, my median would be that 42 and 50. This means that the cowboy hats cost more, that half of the cowboy hats cost more than $42.50 and half cost less. The number that appears the most is 50, so the mode of the data is 50. That means that more cowboy hats cost $50 than any other price. Find the range in any outliers. What we know, our range, we find out that it's going to be that 45. The limits for the outliers, the way that we do it, once again, we do our IQR. So we have that 45. 45, we did our range, times 1.5. What we get is 45 times 1.5 gives us 67.5. So if we did our subtraction, I don't know. What we do is we find out apparently 67.5. We'd have to find our IQR. So our interquartile range, it would put us between 12.50 and 72.50. So $75 is an outlier, which also makes sense. Look at how far away it is from all of the others. Here's the line plot. It shows the number of magazines each member of student council sold. Find the median, mode, range, and any outliers in our data. So easily enough, if we were doing this, like I said, mode is always the easiest. So for our mode, it's the one that has the most. It is 20. Let's do our median now. So smallest, biggest, smallest, biggest, smallest, biggest, smallest, biggest, smallest, biggest, smallest, biggest. Whoop! Even though I've got two of them, it would have to be the median of, or the mean of those two. But it's 20 plus 20 divided by 2. That's 40 divided by 2, which is 20. So our median here is 20. Additionally, for our outliers, what we find is that we have a range. Our biggest, 25, and our smallest is 17. So we have a range of 8. Since our range is 8, if we do with our median, that's 20 plus 8, 20 minus 8, we don't have any outliers. That's how we do this. Same kind of as last one. The line plot shows the amount James deposited in his savings account each month. Describe the data, including the measure of centers. Already, we know that that's the mode we see the most. The median, if we went through, biggest, smallest, biggest, smallest, biggest, smallest, biggest, smallest, biggest, smallest. Oh, we're between those two. So we got to find that's the $47.50. The mean, we add up all of our numbers. So 35, 3 times. 40, 1 time. 45, 2 times. 55 times, and 75. So we add all of those up and divide by the number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what we found there is that it was 12. We divided 12. We find out that our number is 560. So with our number being our top number, our numerator being 560, we divide it by 12, we get our $46.67. So the range of our data is our biggest minus our smallest, 75 minus 35, or $40. Our interquartile range, Q3 minus Q1, or $50, minus that is equal to $12.50. So half of the amounts are between $37.50 and $50. So the one outlier is, again, 75, which it looks like it because it's far away. But you can't always trust just because it's far away. Although in a lot of times when we see a great clumping of data and then one very far away, that gives you a good idea that it's an outlier. Here, if we looked at this one, the line plot shows the prices of sweaters in a store. Describe the data, including measures of center and variability. So if we were going to be doing this problem, we're going to be adding all of these up again. So we already know what our mode is. Our mode is 25. That's pretty easy. Let's find our median. Biggest, smallest, biggest, smallest, biggest, smallest, biggest, smallest. We got 2. We'd have to find the mean of that, but they're the same number. So that means that our mode so far is 25. Our median is 30. Our mean, we once again have to add all of these up. So this is 25 times 4. It's 100. This is 30 times 2, 60. 40 times 2 is 80. 45 times 1, and 65 times 1. We add all of those up. 100 plus 60 plus 80 plus 45 plus 65. We get 350. And we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. We divide it by 10, we get 35. So we find that our mean is 35. If we found our interquartile ranges, we do all of that. We already know that our median right here was technically right in those two numbers. So we have 5 on each side. 1, 2, 3, 4, 5. So right there is our Q1 between the two of them because we go cross, 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 cross. The other one, we go cross, cross. We go cross, cross. So that one's our Q3. If we found the range between our biggest and smallest, we do the range between the QR. The IQR is 40 minus 25 because the IQR is equal to Q3 minus Q1. Q3 is 40 minus 25. So our IQR is 15. We want to find any outliers. What we do is it's multiplied by 1.5. 15 times 1.5. We get 22.5. So now we add that to our Q3. Once again, our Q3 was 40. So we add that to 40 and we get 62.5. That means that's too big. It's our outlier. Then we subtract it from Q1. Q1 was 25. That's already the smallest, which means our only outlier is 65. So we know when we have the median, that means half of the prices of sweaters are more than 30, half of the prices of sweaters are less than 30. The average price of the sweater is $35. Most of the sweaters cost $25, but that outlier, $65, changes the price of all of that. So if we removed the outlier, since our outlier is bigger, all of our median and mean would get smaller, especially the mean. The mean would get smaller. The median might, but the mode does not change. So let's look at problem 1 in our guided practice. Make a line plot for the set of data. So first, let's do 160. 160, I have that. I don't see any others, so I get 1 dot. Let's see the next one. I'm just going to start counting. 190, I'm going to put a 190. 210, I'm going to put a 210. Another 210, I'm going to put a 210. A 200, I put a 200. An 85, I'm going to put a 185. Another 190. Another 190. Another 185. Another 200. Another 190. Another 210. Another 190. Another 185. Another 200, and another 200. So, what we find, mean, median, mode, then I want my Q1, Q3, I, Q, R, and our outlier. So I'm going to write it like that. So our mode, easy, is 190. Let's find our median. Cross, 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 cross. It would be the mean of those two, but it's the same number. So it's again 190. If we found the mean of all of those, we would add all of that data up. So it'd be 160 plus 185 plus 185 plus 185 plus 190 plus 190 plus 190 plus 190 plus 190 plus 200 plus 200 plus 200 plus 200 plus 210 plus 210 plus 210. So I've added all of those together. I have a total of 16 points of data. So I divide it by 16. And my mean is going to be 181 and 625 thousandths. So that's what we get here. Now let's look. We already know, actually I don't want to erase that. I guess I do want to erase it. So we want to find our interquartile range. Our median is right there. So let's see. We're going to do cross, 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 cross. Right there. That's our Q1. So our Q1 is 185. Let's do our next ones. I messed up a little bit, so we're going to go back. I still think it's the same thing, but we're going to check our median again. 1, 2, 1, 2. Well, let's see if we have this. This is 3. That's 3. This is 4. And then that's 4. So if we were looking at this, it would be, we want to make sure that there's an even amount on both sides. No, I was right. Okay, so this would be included. We have 8. We have 8. So let's find our interquartile range here. Cross, 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 cross. It's going to be between 185 and 190, which makes our Q1 187 and 5/10. So if we did our Q3, we would do our cross, 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 up. We already know that it's going to be between there. So we know that our Q3 is 200. Our interquartile range is 200 minus 187 and 5/10 because it's Q3 minus Q1. So if we did our math using our calculator, we'd find that it is 12.5. We multiply that times our 0.15 to find if there are any outliers. That is 18.75. So it's Q1 minus that amount. So it's 187.5 minus 18.75. That gives us $168.75. Hey, this one right here is $160. That means that it's below. So this is an outlier. Then we have to add it to that 200. That gives us 218.75. We don't have anything that close. So our only outlier is 160. For your homework, you're going to do page 867, numbers 1 through 6.